Today we're going to learn about linear and quadratic function. Okay, so we learned about linear functions last time. What does linear function look like? F of x equals 2. Since it's a linear function, it's a line. So last time we learned every line is a function except what kind of line? A vertical line. And what does this function look like? Yes. Excellent. F of x equals to mx plus b. You guys remember this? So this is our linear function. Thank you. So f of x equals to mx plus b. Today we're going to learn another function that is another sort of a form, not just mx plus b, but it's going to be a different. It will look different than this. Okay. So it's called. Guess what it's called? Look at the topic. Look at our topic today. It's called quadratic function. And quadratic function would not look like a line. It would be a curve. So this will be a first curve that we're going to learn. Okay. And it's going to be a function. It's going to pass that vertical line test. Right? Okay, so may I show you the quadratic function now?
Wait, no.
Okay, go ahead and write it down. I'll wait. Okay. And because we said that every line is a function except for a vertical line, we need to say something about the slope of this line. Right? What do you have to say something about the slope of this line? It cannot be what? It could be 0. If the slope is 0, what kind of lines do you get? It's a horizontal line. So it's fine. Undefined. So we gotta say m can't be undefined, right? Because if it's undefined, you get a vertical line, and vertical line is not a function. So that's why we need to write this down. This does not include any vertical lines, which means m cannot be undefined. Okay, so because then vertical line will not pass a vertical line test, right? Okay. So then, what does the quadratic function look like? Here it is. It looks something like this, okay? I'm going to call that function g of x because I already used f. A function g defined by g of x equals to ax squared. Notice now we have x to the second power term, right? Before we only had x to the first power. Now it's x to the second. Plus bx plus c, where a cannot be 0, is a quadratic function. So whenever you see this form, as long as a is not 0, it's called a quadratic function, and it's a function. It's going to pass a, what kind of test? Vertical line test. Okay, and you're right. Not every curve will be a function, but this will be a function. Okay, and we're going to graph this in a minute, but write this down. Okay. Yeah, this is the form for quadratic function. Ax squared plus bx plus c, where abc is some real number, right? And a can't be 0. Okay, because if a is 0, what happens to the quadratic term, the x squared? It goes away, so it's not a quadratic function anymore. Okay, as a matter of fact, if a is 0, it just simply becomes a linear equation, linear function, right? Doesn't it? It's the same thing as mx plus b, right? Instead of m, you have b. Instead of b, you have c. So it becomes a linear function. So if it's a quadratic function, a can't be 0. Okay, so write that down. And does anybody know what this graph look like when you graph this? I think some of you might have seen this maybe in intro or something. Eunice, what do you think? Yeah, the either smiley face or the sad face. What is that called? Yes, parabola. Very good. So it turns out whenever you graph this function, ax squared plus bx plus c, you get a parabola. So this graph of g is a parabola, and it's a domain, of course. Domain is of course all real numbers, right? So you guys remember what a parabola is? You either get a smiley face. When do you get a smiley face? Do you guys remember? When does it open upward? Yeah.
When it's a positive.
What is positive? When anybody remember? Okay, almost. What is positive? You're right. If something is positive, you get it'll be a smiley face. Okay. When something is negative, it'll be a sad face. Yeah.
When the slope is
not slope. Not slope.
When
No, when? Let me tell you. Yes, Tajwa?
when the equation is
Well, how do you know when the equation is positive? Dana? When that coefficient of the x squared term. Okay, so when a is positive, it opens upward. When a is negative, then it opens downward. You kind of think of it as, a positive, you get smile. If a is negative, then you get sort of a sad face. Does that make sense? I'll show you how it is. I have a good illustration to show you. So write this down. So when a is positive, in other words, if the leading coefficient of this quadratic term, right, the term for the quadratic term, if a is positive, like if a is like negative, positive 3, then it's going to, the parabola will look like this. If a is negative, the parabola would look like this. Okay, so I'll show you what that means in a minute. Okay, here we go. Let me actually graph this parabola for you, okay, on this graphing program. So you just take a look at it. So I'm going to put down what it, so look, it says y equals f of x, right? You know, it's just in function notation, isn't it? So so f of x equals to what? What should we plug in if I want to plot that parabola? What was our equation for a quadratic function? Yes, a x squared. To do x squared, I could just type xx. Okay, isn't that nice? Because that means x times x, right? Ax squared plus what? Plus bx plus c. And I'm going to make this thing thick enough so we can see. There you go. Right now, it's a horizontal line because my a happens to be what, guys? 0. So we don't want a to be 0. Remember, if a is 0, you get a line, right? So we want to make sure that a isn't 0. Let's make it a positive. Okay, let's plug in positive 1. Here we go. There you go. You see, we get a parabola. We get this curve. This is what this equation, right? Plus, if you were to plug in a bunch of points, right? This is what you get. Isn't that nice? What would happen if I were to plug in a equal to negative 1? It will be the other way around. Look, negative 1. You see? I can move it down a little. It's down here. See, you get. See, you get. It opens downward. Does this make sense?
Yeah.
All right. So it's kind of interesting. Look, I can move the a up and down like this. See? I can move it manually. I can make it go automatically. See? See, as the change of a is going from like negative 10 to positive 10, I think, slowly. So that's what happens. Do you see kind of interesting happens when? Okay. All right. Now, so right now a is 7.2. Okay, whatever. But let me change it to back to 1. Okay. Look, what happens if I change? Do you think the parabola will get narrower or wider if I change the value of a to maybe 2? You think it's going to be wider? Watch this. I'm going to change it to 2. It actually gets narrower. What do you think if what if I change it to a 4? Do you think it's going to be narrower or it's going to get narrow? So it turns out as you change the, no, I'm not going to, okay, so as you change the value of a more like, right, bigger, it gets a lot narrower. But if it gets smaller, okay, look, 0.6, 0.8, look what happens. It gets wider and wider, doesn't it? As you, like, it's 0.2 is really wide. Okay, and of course, when it becomes 0, it's a horizontal line, isn't it? Because a is now gone. The term with x squared is gone. And again, it's going to get wider. If I do negative, like negative 0.6 is wider. Of course, if I go negative 1, it gets narrower and narrower and narrower. Kind of nice to see, okay? Any question there? All right, so I'm going to keep a to 0.2. Look what happens if I change the value of c. Right now, my c is 0, right? Look what happens if I change the value of c. C turns out is your y-intercept, just like, you know, the y-intercept of a line. So if I were to change c to 1, guess what's going to happen? Anybody have any guess? Yeah, it's going to go up to 1. You see, isn't that nice? What if I change this value of c to negative 3? It's going to go down to negative 3. Okay? Value of b is really interesting. Watch this. So let me change the value of c to 2. And let me change the value of b. Look what happens. No matter what I do with b, right? It has to have the y-intercept at 3, right? So it's going to, when I change the value of b, it just goes to left to right as long, and then the y-intercept stays at 2. You see what I mean? Do you see how that works? All right. Anyway, so that's more than what you need to know about. But you really have to know that if I change the value, okay, let me move it back to where we were. Okay, if you change the value of a to positive, what happens? It opens upward. And if you change the value of a to negative, what happens? It opens downward. That's what I want you to know for now. Is that okay? That's all you need to know for now, so far, okay? So what we're going to do now is we're going to then graph one of these quadratic formula. Today, on your homework, you're going to be graphing these, and you're going to do one other thing. Okay, so let me explain that in a minute. But here is the quadratic formula. H of x equals to x squared minus 6x plus 4. Okay. To graph this, only way we know how to graph this is using the tables of values. And so, which number should we use to plot these points? Well, what's the easiest x you could plug in?
0.
So let's do 0. Let's plug in 1, 2, 3, 4. Let's go up to, because it's a curve, I don't want to just do 3. Let's go up to 5, okay? So go ahead, everybody. Actually, let's go up to 6. Okay, so I want you to plot or find the order pairs from 0 to 6. Okay, go ahead, everybody try. I'll wait. All right, let me do the first one for you, because it's pretty straightforward. When you plug in 0, don't you get 0 squared plus 6 times 0 plus 4? What is that, guys? For x equals 0, what do you get for your h of 0, which is y? 4, right? You just get 0 minus 0 plus 4.
Yeah.
Let's plug in 1. What do you get when you plug in 1? 1 squared minus 6 plus 4, what is that?
-1.
Yeah, -1. Yes?
Yeah.
You do the same way for all the other ones, right? What do you get when you plug in 2? You get 2 squared, which is 4, minus 6 times 2, which is -12 plus 4, you get
This is the weirdest thing ever.
-4, isn't that right? This is weird? Really?
No.
Oh,
It's
okay.
like a parabola.
Alright, go ahead, finish it up. Finish it up. Okay, finish it up if you're not. So, how many people got for 3? When you plug in 3, who's got this one? How about Dakota? What'd you get? You got -5? And I think I got the same. There you go. What about for 4? Yes, Angel? -4. What about for 5? Yes, Matthew? -1. And what about for 6? Yes, Eunice? 4. Did you all get that?
Yeah.
Alright, and then I asked you to plot these. Did you get this graph?
Yes.
It's kind of slow. You see, you get like a little,
I got that.
you get a little happy face, kind of, right? So, now, by the way, you see this point right on the bottom?
Yeah.
That's called vertex. Okay. By the way, is this going to be the lowest point every time, or it could be highest if you have the upside down. If A is negative, right? Depending on what A is, if A is positive, this will be the lowest point, right? And if the A is negative, it will be the highest. By the way, let me just tell you that we really got lucky graphing this. Why do you think I say this? In other words, what I mean by that is, by the way, my vertex is 3, -5, right? On your homework tonight, they're gonna ask you to find the vertex. Okay. So let me show you.
How do you do the vertex? We're just right there. And the one in the middle.
It's a starting point.
Okay, so let me show you why and how to find vertex and why it's important to find the vertex. And let me show you why we got really lucky. Because you know how we start with 0, 1, 2, 3, 4, 5, 6,
Yeah.
right? And we got these nice points, right? Well, do you think it's gonna happen every time when you start with 0, 1, 2, 3, 4? Not really, because look, imagine that I have a parabola that if it looked like this, that'd be fine, right? I could well, no, this would not be good either, because look, if I were to plug in 0, 1, 2, 3, I would only get half of this parabola if I were to plot those points, right? Because all the other, right? The other side of the parabola is on the negative side. You know what I mean? So we really got lucky because here we started off with 0, 1, 2, 3, 4, 5, 6, and we got sort of nice, right? We got the whole parabola. But imagine if parabola looks something like this, or even worse, if it looks something like this. Then if you were to plug in 0, 1, 2, 3, 4, 5, 6, you will only get this part of the parabola only. You know what I mean? So when you do your homework and then when they ask you to graph a parabola, you need to find the vertex first. Why do you think I say this? Yes, sir.
Because everything else will go.
Yeah, once you find the vertex, you would just need to find 2 other points on the right side of it and 2 other points on the left side of it. Okay? So for lines, how many points do we use? 3. For a parabola, I want you to use how many points? 5. The vertex, and then 2 other points on the right side of it, and then 2 other points on the left. And now the question is then, what's the question that we should be asking? How do we find the vertex, right? Because if I just gave you an equation, right, that is quadratic, how would you know where the vertex is? Well, you're in luck, because I know a formula to find the vertex. You all want to know this? Yes. Let me show you what it is, okay? Let me show you what it is, because you want to know, because you want to do your homework correctly. Are you all ready for how to find the vertex of the parabola? Well, let me tell you how to find the x-coordinate of the vertex. Because if I tell you what the x-coordinate of the vertex, how do you find the y-coordinate? You simply
Plug it back in.
Plug it in, right? Isn't that how we got -5, right? So if I could tell you, if we could figure out the x coordinate of the vertex, like for example here, this was 3, right? You could always find the y coordinate by plugging it in, right? Does that make sense? No, if I told you that the vertex was 3, could you figure out the y coordinate of this vertex? Yeah, how do you do it? You plug it in just like how you did it in your table, right? Didn't you, once you, like if I knew this was 3, don't you plug in 3 to the equation and find the y value, right? That's easy. If I give you the x value, you could always find the y value, can't you not? So the key is then to find the x value of the vertex, and here it is. Write this down. Fact, you're going to need this. It turns out that x coordinate of the vertex is simply -b/2a. And what do you think? Where do you think this b/a came from?
Slow.
No, b and a is from the equation. F of x equals to a x squared plus bx plus c, right here. Okay, that's where it comes from. I shouldn't write x equals to, right? So that's the x coordinate of the vertex right there. The fact, the x coordinate of the vertex is -b/2a. So it's going to be -b/2a comma something. And we know how to find the y. All you have to do is plug it in, right? So that's how you find the x coordinate of the vertex. Okay, so write that down. And we'll do an example. Okay, but write it down first. Okay, this is important. You need to know this. Otherwise, you will only get parts of the parabola when you plot. You can't just randomly choose any 5, right, points, right, any 5 x's. Because then you're just going to get some part of the parabola. It will not look like a parabola, okay? So let's see whether or not this worked for our previous example. What was our x coordinate of the vertex again? It was, what was it? It was 3, right? So let's plug it in. So our equation was this, right? h of x equals x squared minus 6x plus 4. What is your a in this case? By the way, it's best if you write it into an addition, because you could see that your a is what, guys? Your a is not x. Your a is, what's the coefficient of the x squared? 1. What's your b? -6. What's your c? Yeah, 4. Isn't that what it is? Okay. Look, remember, it has to be in this form. A x squared plus what? bx plus c. Right? Do you see why I changed this addition? And as you can see your a and b really easily. Your c, of course, is 4, right? But this formula doesn't really require for you to have c. But nevertheless, there it is. Now let's plug into this. Everybody go ahead and plug into -b/2a. We should get what? What should we expect to get? Was our vertex, x coordinate of the vertex -3?
0. Wait, what? Never mind.
What was the x coordinate of the vertex, class? 3. Okay, it was 3 -5. So go ahead and plug it in, see what you get. You guys got -3? That would be not good, because that's not what the x coordinate of the vertex is. It should come out to 3. Does it not come out to 3? It's -b/2a. It's not b/2a. Please be careful. Right? So you should get 3. That's the x coordinate of the vertex, right? Do you see? What's negative times -6? +6. +6/2. Isn't that 3? So you don't get -3. You get +3. It's -b/2a, not b/2a, guys. Please. There's a big negative there. Okay? Does that make sense? So it does work out, doesn't it? And how do you find the y value? Well, you just plug it in, right? So it's basically you find h of 3. Isn't that what you're doing? You're plugging in 3 in place of h. So that's how you find the order pair for the vertex. It's 3, comma, whatever h of 3 was. What did it come out to? Negative, what was it? Let's go back up. Look at your table, right? When you plug in h equals 3, we got -5, right? So it comes out to -3, -5, right? Do you see what I mean by h of 3? I just want you to plug in 3 in place of x, and you give the y value. Right? So that's my vertex, 3, -5. You see how it works out? Yes?
So, we want to do in the homework is put 2 x's.
Okay, so let's do, yeah, exactly. Let's do one example like, so let's say I have this equation, right? Your A is 2, B is 4, C is 3. Okay, go ahead. Everybody find the x-coordinate of the vertex. See what you get. It's easy to see that the x-coordinate of the vertex will be what, guys? Simply, what would it be, guys? Let's plug it in. Yeah, negative times something over 2 times something. What do I plug in for B? What do I plug in for B? 4. What do I plug in for A? What do I get? Negative 4 over 4, which is negative 1. It's not 1, is it? It's negative 1. So how are you going to do a table? Here's x. Yeah, here's x. Here's the k of x equals to x squared, 2x squared plus 4x plus 3, right? And here's the order pair, x comma y. So what are you going to start off with? What number do you need in the middle? You need 1. Very good. Negative 1. So you need negative 1 here. And what are the 2 other values you need? This is the what are the 2 other points you're going to use? What is the point after negative 1?
0.
Thank you, 0. It's not. And then what is the next one? 1. What are the 2 other ones to the left of it? Negative 2 and? So these are the points you're going to use. These are the 5 points you need. Now, how do you find them vertex? Because they're going to ask you to find the vertex. What's going to be negative 1 times what is going to be your y value? How do you know the y value? You what? Plug it back in. So you're basically looking for k of negative 1, right? So it's 2 times negative 1 squared plus 4 times what? Negative 1 plus 3, right, guys? What does that give you? You get, what's negative 1 squared? That is simply positive 1. You get 2 plus, this is negative 4, plus 3, which then becomes, what does that give you? It is simply 1. Does that make sense? So it's negative 1 comma 1 is your what? Vertex. So you have to find the vertex whenever you are graphing these parabola. You know how when we were graphing linear equations using slope-intercept form, you graph the y-intercept first? So the same idea. You need a starting point, right? And then you need the 2 other points on the right and 2 other points on the left. Okay. Otherwise, you could just get part of the parabola, okay, which is not good. Do you understand what to do? And do we know how to, okay, and then you could do all the same for the other ones. So on your homework tonight, that's all you need to do, okay? It asks you for some other information. Don't worry about those. Just give them the vertex and graph. Any questions? All right, good.